In this video, we are going to see about the uninformed search algorithms. Usually, the search algorithms are used to find the solutions or used to find the goal nodes. There are two types of search algorithms, informed search and uninformed search algorithm. In informed search algorithm, there will be an information related to the goal node, where the goal node, how much cost it takes from the start node to reaching the goal node. Whereas in uninformed search, we does not know any information about the goal node. It is also known as the blind search. The uninformed search algorithm have no additional information on the goal node other than the one provided in the problem definition. There are various types of uninformed search algorithms: breadth first search, uniform cost search, depth first search, depth limited search, iterative deepening depth first search, bidirectional search, etc. In breadth first search, the tree or the graph is traversed breadthwise. It starts from root node, explores the nodes which are in the first level, and then it moves towards the next level. It is implemented using the common data structure called as queue, which works on first in first out fashion. So let us go through the example. If we take this example, that it has 4 levels. In level 1 it has node 1, in level 2 it has nodes 8, 5, 2, in level 3 it has 4 nodes, and in level 4 it has 2 nodes. The breadth first search algorithm works in the following fashion. It starts with the first node, that root node which is in level 1, that is node number 1. Then if it examines that node, then it travels to the next level where it has 3 nodes 8, 5 and 2. It travels from left to right, and then it goes to the next level. Once it explores all the nodes in level 2, it goes to level 3, and it goes on. The nodes which are searched by this breadth first search algorithms are 1, 8, 5, 2, 6, 4, 3, 9, 10 and 7. The algorithm for depth first search is given here. This is a pseudocode for breadth first search algorithm. Next algorithm is the uniform cost search algorithm. Here it considers the minimum cumulative cost from start node to the next node. So let us take the example. Here the source is located at the level 1, and in second level it has 3 nodes A, B and C, and in third level it has 3 nodes G, F and E, and in fourth level there will be a destination node. The uniform cost search travels from the source node to the node which has the lowest cost. For example, here the source node is located, and then when it moves to next level, it goes to node A because it has the cost of 1. If we consider the node B, it has a cost of 3, and node C has a cost of 5. So it moves to node A. After examining node A to check whether it is a destination or not, then it checks for next neighboring nodes. The next neighboring node is G, which has a cost of 4 from node source to G through A. So here G node has a cost of 3, G node has a cost of 4, B node has a cost of 3, and C node has a cost of 5. The node which has the minimum cost is B. So the B node will be examined. After examining B, it found the next new node as F, which has a cost of 8. So at this point it has 3 nodes: node G with a cost of 4, node C with a cost of 5, and node F with a cost of 8. It travels to the node which has low cost, that is G, which has a cost of 4. It travels in this fashion. Uniform cost search is a search algorithm. It is used for traversing a weighted tree or a graph. The primary goal is to find the path from goal node which has the lowest cumulative cost. The uniform cost search expands nodes according to their path cost from root node. It can be used to solve any graph or tree where the optimal cost is in demand. It can be implemented using the priority queue, which gives the lowest cumulative cost. This is the algorithm and pseudocode for that. The advantage is it is optimal, and the disadvantage, it may stuck in infinite loop. The depth first search algorithm is one which travels in the depth-wise manner. Here, let us consider the example. There are 4 levels. Level 1 has node 1. Level 2 has 3 nodes 2, 7 and 8. Level 3 has 4 nodes 3, 6, 9, 12. And level 4 has 4 nodes 4, 5, 10 and 11. So it travels from node 1, and then it moves to the leftest node. So then in the next level it moves to the node which is in the left corner, left end, that is node 2. After examining node 2, it moves to the next level, which node is in left side. So it examines node 3 and then node 4. After examining node 4, it moves to node 3 and node 5, and then examines node 5. So in this manner, it traverses depth-wise from left to right. The depth first search algorithm, this is another example for depth first search algorithm, and this is the algorithm for that. Another algorithm is depth limited search. It is a version of depth first search algorithm where where the search is limited at a particular level. The depth limited search algorithm is similar to depth first with a predetermined limit. It can solve the drawback of infinite path in depth first search algorithm. It is terminated with the two conditions of failure: standard failure value and cutoff failure value. Standard failure value is one where the problem indicates that it has no solution, and cutoff failure value is one which defines no solution for the problem within a given depth limit. Advantages: it is memory efficient, but disadvantages: incompleteness and not optimal. This is a pseudocode for that. Another algorithm is iterative deepening depth first search algorithm. In this algorithm, the search will be taken place iteratively for each limits. For limit 0, it searches only the root node. In limit 1, it searches the nodes which are in level 1 and level 2. In limit 2, it searches the nodes which are in level 1, level 2 and level 3 and so on. So it is an iterative procedure. The key points is that it limits it gradually increasing the limit from first 0, then level 1, then level 2 until the goal is fine. This will occur when the depth limit reaches D, the depth of the shallowest goal node. Iterative deepening combines the benefit of depth first as well as breadth first search. This is the pseudocode. And another last category is bidirectional search, where there will be a two mode of searching is carried out, one from start node, another from the goal node. So the idea behind bidirectional search is to run two simultaneous searches, one forward from initial state to backward and the another from backward, hoping two searches meet in the middle. The bidirectional search is implemented by replacing the goal test with a check to see whether the frontiers of the two searches intersect. If they do, a solution has been found. It is important to realize that first such solution found may not be optimal even if the two searches are both breadth first. Some additional search is required to make sure that there is another shortcut across the gap. The reduction in time complexity makes the bidirectional search an optimal one. Thank you.